The Being an Engineer podcast is a repository for industry knowledge and a tool through which engineers learn about and connect with relevant companies, technologies, people, resources, and opportunities. Enjoy the show.
There could be some young or prospective engineers that are listening, and if so, I would say go for it. I was selected to be an engineer over people that were more qualified than me, and it was because I smiled, I was as pleasant as I could be, and they chose me because I could add with my personality.
Hello everyone, welcome to the Being an Engineer show. Today I have a very special guest, a mentor of mine. His name is Joseph Larsen, aka Joko Engineering, and I'll explain that in a moment. I'm your co-host, Rafael. Today we're doing something a little bit different. We're doing not only a podcast, but also a video call. So we'll have the link to the video call if you want to see our faces and you want to see some of the PowerPoint slides that we'll be sharing. It'll be just in the description below. I know a lot of people like to listen to the podcast driving, like myself. So you're only going to miss out about 5% of the whole show if you don't watch it. So 95% of the content will be auditory. So you're fine if you just want to listen to it. So Joseph, welcome to the show.
Hey, it is great to be here. It's an absolute honor.
Thank you. So let me set the frame of the whole conversation in the podcast. I want to tell our audience how we met and how this all started after quickly introducing you. So Joseph has a huge YouTube channel. He has 32,000 subscribers, as you can see from my screen, those of you that are watching the video. Some of his videos have over 500,000 views. So he's been pretty successful at the YouTube thing. In his YouTube channel, he has tutorials on SolidWorks, Freecad, Calculus, Engineering, Turbocharging dynamics, and more. He has a bachelor's of mechanical engineering from Arizona State University, and he is a handles design engineer at Gore Associates. So let me set the frame here. This is how we met, our interesting story. I was trying to get my CSWP SolidWorks certification. SolidWorks is basically a CAD program, and the CSWP is one of the most important certifications that you can get for it, to show employers and everyone else that you're proficient in SolidWorks. So I was browsing YouTube, like many of you have done before, and looking at all these different tutorials, and some of the best tutorials came from this YouTube channel called Joko Engineering. To be specific, it's called Joko Engineering Help. So I watched a couple of tutorials, and I thought to myself, I want to reach out to the owner of this YouTube channel to see if we can make a personal connection and just simply tell him that I really appreciate his content. So I reached out. He emailed back right away, so I was surprised because so many followers. I didn't think that he was going to respond. The amount of correspondence he must receive must be outstanding. And we hit it off right away. He was super nice. And we scheduled a Zoom call, a video call, and the chemistry was there. He became my mentor. And I then find out that he also lives in Phoenix, like myself. Like, what are the odds, right? Like, I'm looking for SolidWorks content, and we both live in Phoenix. We're basically neighbors. And in conclusion, I just wanted to say that I feel like I'm blessed. I seem to come across great people. I attract great quality people, and I'm very thankful that the universe has done this, that God has done this for me, and I'm very happy to be talking to Joseph today. So welcome to the show, and here I'm going to ask you a couple questions about... let's see. First, let's start off with W.L. Gore, the company that you work at. It says that you're a handles design engineer. Could you explain what that is?
Yeah, that's right. And thanks again, Raf. It's really great to be here. So with W.L. Gore, you probably know Gore from Gore-Tex. They can make jackets that will breathe with air going through them, but they won't let water through. It's a material science company, and I work in the medical division. So the same technologies that are applied with these jackets can create materials that work with medicine, particularly with intravascular surgeries. and I work certain handles that can run catheters through veins and parts of the body to allow access into places that are would otherwise be very, very invasive. So these materials with what we call EPTFE as a material allow people to recover from certain injuries and health problems a lot more quickly and easily than with other solutions. So specifically, I design medical handles that work mechanically to run certain catheters and delivery systems.
So when you say medical handles, does that mean the handle that one uses to hold on to the device? Is that what a handle is?
Yeah, good question. If you have seen, sometimes you see it a lot in movies, intravascular surgeries where you have a physician holding on to a device that has a big catheter on it, and they'll steer the catheter through veins, and this handle has certain controls on it that allow the catheter to be steered in multiple directions, right? That would be a medical handle if you've if that makes sense to viewers.
Okay. So it's something that your hand is going to grasp onto. Is that right?
That's right. Yeah.
So forgive for my ignorance, but let's see. I've done a couple handles before on SolidWorks. Some may need surfacing, so others may not. How complicated could a handle be?
I've seen, in fact, some of the most complex models that I have dealt with have been handle models. So, in all of my time in engineering, they can get really complicated. Yeah.
When you design a handle, do you design it so it conforms to the fingers, like it has the little bridges for each finger, or no?
We don't. Ergonomics and certain elements of how it's designed are really, really a big deal. But I haven't seen handles with any kind of finger contours. Um, it's more a concern of, can you look at this handle and intuitively know how it works? In a situation where someone's life is at stake in a surgery, you want to be as simple as possible, and part of that is having very simple kinds of curvature and things like that. So
Okay. So I guess that's your specificity, right? Handles for medical devices.
right, yeah.
Is that right? This is very interesting. We haven't had someone on the show with that specificity. Let's see. What should an engineer that maybe works on medical devices know about handles if we don't specialize in that? Couple things.
What should an engineer know about handles if they don't specialize in it? That's a great question. And I think it depends on what the surgery is for. Even something like a surgery on the heart can vary so much from a surgery on, say, an aorta or other part of the body. I would say as ergonomic as possible. At all times, you want the physician to be able to grasp the handle in a comfortable way that doesn't lead to any kind of fatigue, because some of these surgeries can take a long time, some of them can be a short time. You want to be able to make the handle in a way that you have a lot of safeties. You don't want to accidentally hit a button at the wrong time and have something happen that would endanger the patient. So consider a lot of safety interlocks and consider making things work with as few steps as possible.
Okay. A couple things that go through my mind. We have the same hands, but handles may change. If one handle works for a specific medical device, then why not use the same handle for the other medical devices?
That's an excellent question. And I think it goes into consolidation. I think you find that especially I think most medical handles you would say are injection molded, and the tooling for injection molding is so expensive. There is tons of opportunity to be able to consolidate parts if possible, because if you pay 10, 20 grand for tooling, you want to use that as much as you can, right? So I would say the only reason for not doing that is if you have a particular functional problem with using handles. And in our case, there's a lot of times when you have a completely different implant or something else that you have to deploy, and it's just you can't do it just on the basis that the implants are incompatible. Does that make sense?
I'm a super visual person. It would be extremely helpful if you could maybe pull up an image from Google and maybe like hover your mouse over the area that you're referring about, and we'll be as descriptive as possible with our language so that people at home just listening to the audio can follow along. What do you think about that?
Yeah, that sounds great. Let me see if I can find a handle for you.
For sure.
I think I've got a really good one here. I'm just grabbing a second one.
Take it away. Yeah.
All right, so we're looking at some handles from a company called Abbott on top there. It is this is called MitraClip for a procedure that repairs certain leaflets in the mitral valve. You can see that you have a handle with a knob sticking out on it, and you would twist that knob kind of like you're opening a jar of pickles, if you think about the ergonomics on that. Whereas below you have an Edwards handle, and the difference would be that you have a knob built into the side of the handle, and you would kind of move that the same way you would scroll the wheel of a mouse. And this is the same function. You're turning something, but the ergonomics are very different, and it leads to a different experience when you are performing the surgery. So when we evaluate a design of a handle, it is really important to understand the voice of your customer and know what is the best to do when. Sometimes opening a pickle jar kind of ergonomics is way more effective than twisting something that's in your hand, like the wheel of a mouse. But other times, that's not such a great solution. So these are all factors that should be weighed when designing a handle.
Excellent. Yeah, I've never had such a close look like this or paid such close attention to the handle of a medical device. Usually, the focus seems to be where it's cutting the tissue or where the motor is, but the handle is absolutely instrumental. If one gets tired from handling the device, it could be dangerous. So, very cool. Okay, so what's the favorite thing about your job?
That's a great question. Gore is such a wonderful place to work for, and it's a great company. They've been in the Fortune magazine top 100 places to work for I don't know how long, but years and years. So that is always great to have a job that treats you very well. But I think I love the freedom of being able to design things from scratch, see projects from cradle to grave, and actually make a difference in helping people's health improve.
Okay. And tell us a little bit about your YouTube channel that has 32,000 subscribers. How did all that start out, and how did you keep on growing it?
Yes. That was a funny story. I was a student at ASU Polytech, and I was pursuing my degree, and I really, really wanted to learn CAD. And interestingly enough, with the degree program at the time, there was just not very much CAD to take that would have helped my degree. The accreditation, I think, was set up for a different kind of education. So I was able to take one CAD class, and it was half GD&T. But from that half CAD class, I learned how to fully define a sketch and do simple assemblies, and that got the ball rolling for me so that I could be able to teach myself how to do a lot more. And almost everything I've done with CAD is self-taught, and every time I would learn something new, I would put it on a YouTube channel, and it was almost out of spite that I wanted to do it better than my university did for other people. So I wanted to make it accessible, and hopefully people would enjoy CAD the way that I have. It's been quite an interesting journey because I didn't actually expect it to get very watched at all, but it looks like people are following it and enjoying it, so it's turned out to be pretty interesting.
Yeah, when you actually gave me a lot of pointers on how to pass the CSWP that I passed with 100%, in large part thanks to you, once you gave me all that content and those tips, I made my own YouTube video to help other people pass that CSWP test. And every week I get messages on LinkedIn, people thanking me for putting that content out there. So I just want to relay that on to you because I don't think I ever told you that. So thank you. Thank you for passing that knowledge to me.
Oh, thanks, Raf. Yeah, it's kind of like Les Miserables, that story of Jean Valjean, where love and kindness is just kind of infectious and it spreads almost like a disease, but in a good way. Uh, it's really wonderful to see how many people in the world like you are willing to help others and do so even for no benefit of yourself other than just being able to help. So it's really inspiring to see what's happening across YouTube and LinkedIn and all these different places.
Absolutely. And in your YouTube channel lately, you've been talking a lot about FreeCAD. Could you give us an introduction as to what is FreeCAD and why is it useful? Anything you may want to share about that software?
Oh, FreeCAD's a lot of fun. It was the second platform I learned after SolidWorks, and it was a little bit of a steeper learning curve for me, I think, because I just got used to doing it one way. But when I figured out just workbenches and all the nuts and bolts, it became a really fun and accessible and easy to use software that is surprisingly so powerful. There's not that much I can't do on FreeCAD that I can't do on SolidWorks that I couldn't also do on FreeCAD. Um, I think it's a great way to learn, and I would recommend anyone to learn multiple platforms because you can pick up so much on you know what's going on behind the scenes with solid modeling. FreeCAD, for instance, will call something frenette, whereas SolidWorks would say normal to curve. And when you start saying, "Hey, what's frenette?" When you do a sweep that stays normal to a curve, you start to realize, oh, there's frenette equations that are starting to drive the geometry behind this, and you kind of learn little bits and pieces from just even terminology. So, uh, FreeCAD is an open source software, but it's also known as free to use. So you can reprogram it yourself, and it's a very open license. And I love the community effort behind that and behind being so accessible. I have a lot of respect for people who are so generous in making things free to use and free to view the source code. So yeah, I'm probably giving you too long of an answer, but it has just been totally inspiring to be able to use FreeCAD that's kind of built on community and generosity.
Yes, I agree. FreeCAD. But at the same time, I'm thinking a lot of people that are listening may only know one software CAD package, like myself. I only know SolidWorks, and it was a steep learning curve, learning all the bells and whistles, all the terminologies, like you said. But now I'm finally at a place that I feel comfortable with SolidWorks in designing what I have in my mind, and I can do it quickly. Why do it all over again with another software? Because basically what you said, just learning different terminologies and see what's going on behind the scenes. What else did you learn about behind the scenes from learning FreeCAD?
Yeah, I love that. FreeCAD has taught me a lot about analysis. So the FEM workbench, it's the same idea behind running as an analysis in FreeCAD and running one in SolidWorks. But of course, the analysis and package in SolidWorks isn't cheap. So if you don't have access to SolidWorks analysis, FreeCAD is a great alternative to learn the process. And it's you can run thermal analysis as well, which I found to be so interesting because I haven't really done that in SolidWorks. You can, I just haven't done it. And that in itself has really opened up a lot of possibilities in just making complicated things accessible. And in fact, a developer has reached out to me on my YouTube channel and is developing further analysis capabilities. And I'm just starting to get into that. So there's even more content coming for FreeCAD.
So did you say that in FreeCAD you can actually edit the software? Did I hear you say that right?
That's right. Yeah, it's open source, and so you can get on GitHub and make your own version. In fact, there's 2 versions right now that I think in FreeCAD version 20 is gonna merge the fork again between some main developments that happen between Real Thunder and the main FreeCAD. So there's some really exciting stuff happening right now.
What would you say is the biggest downside of FreeCAD?
Yeah, that's a great question. The number one gripe that I hear in the comments is that the user interface isn't intuitive for people. I and some to an extent that can be in the eye of the beholder because it feels like I've used it so much that it just is second nature, you know. Um, it, and I think the main driver behind those comments is FreeCAD user interface can be steep to learn initially, but it makes sense once you start using it, in my opinion.
I see. I think right now is a good time to take a break and tell our listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering. Pipeline partners with medical and other device engineering teams who need turnkey equipment such as cycle test machines, custom test fixtures, automation equipment, assembly jigs, inspection stations, and more. You can find us on the web at www.teampipeline.us. And we are here with Joseph Larsen, aka Joko Engineering. And I wanted to ask you, we were talking about FreeCAD and maybe learning another platform for all of our SolidWorks users and why that may be a good idea. Who tends to be the general audience that uses FreeCAD? Inventors, right?
Yes, I've had both inventors and hobbyists reach out. I've been able to help some people with some of the work they've been doing, and there's a lot of smart people using FreeCAD. And as well, I get a lot of comments from hobbyists that when Fusion 360 changed their license structure, a lot of people moved into FreeCAD and have found a happy home there. So you get a wide variety. I see a lot of inventors, a lot of hobbyists, and a lot of people who may have otherwise have had trouble with the accessibility of other platforms, either by price or anything else, have been able to make some pretty incredible things on FreeCAD.
I'm naturally a curious person, and I can't help but wonder if there's a product in the marketplace right now that was built primarily using FreeCAD as the CAD package.
Yes, I know of a few. I know that some furniture companies have actually made some coffee tables primarily with FreeCAD. And I think during COVID-19, I know of some medical shields to, restrict airflow were also designed in FreeCAD. I'm sure that there's a lot more out there. I just haven't dealt with them.
I see. So I guess with FreeCAD, you can also design the tooling for injection molding. Is that possible or no?
It is, yeah. And I don't know if it's commonly used in injection molding. Particularly, I think FreeCAD has some potential in having more fillet capability, and with injection molding, fillets are so important. So I don't know if too many injection molders use it, but it is possible to run a Boolean and make tooling pretty easily.
So have you ever brought FreeCAD to the attention of your manager or colleagues and say, hey guys, we should do a project in FreeCAD? Have you done that before now?
A little bit. FreeCAD is awesome for things like gears because you can choose your own diametral pitch, number of teeth, everything you want to about a gear, and it just generates the gear immediately. And it's a really great tool. So I've drawn attention to it, but I think with the way that certain files are organized and the file systems we have to use, it's really built around SolidWorks, and so there may not be too much opportunity, but I have used it in past jobs. I worked in heavy-duty diesel in Indiana. In fact, I've got the Indiana flag behind me because I love that area and I really miss it, but I built some heavy-duty diesel aftermarket parts for diesel oxidation catalyst and particulate filters, and FreeCAD was great. It did everything we needed.
Okay. What are some of the biggest challenges you face?
That's a great question. Would that be in the scope of the work that I do every day?
Yeah, let's start out with that. And let's talk about YouTube after that.
I think one of the big challenging aspects of working in medical is someone's life is depending on the product that you're making, and you want everything to be as ideal as possible. And finding a balance between how much detail is realistic to add and being able to actually progress on a realistic timeline can be a little bit challenging. I think there's a lot of prototyping and a lot of testing that is involved with medical devices, and having confidence in everything that you've built and make sure that you've proved it out can be not only extremely important and satisfying, but you want to make sure that you've tested it enough and validated it enough. It seems like always something goes wrong on test day, which is an inherently great thing. You just don't want that to happen to a patient, you know.
I love that mindset. It's very positive.
Thanks.
What makes your life hard on YouTube? Like, what's something about the YouTube platform that you wish were different, maybe?
Yeah, that's great. You know, I've really enjoyed working on YouTube, and it's enabled me to reach people that are exceptional human beings, people like you, people like inventors and hobbyists and other engineers that are out to make the world a better place. Working on YouTube can be a little bit stressful when you see all of the demonetizations and other limitations that happen depending on the content that you put out. And so I always want to be mindful to be quite politically correct to make sure that I can remain accessible and help as many people as I can. So that can be kind of a stressful thing. Sometimes you get people who are extremely negative, and it's really gotten me to get used to just shrugging people off and realizing some things don't matter.
How can someone be extremely negative at the content that you provide? You're just showing people how to do stuff on CAD and giving some advice. I can't find anything negative about that. I'm sorry.
I like that. Yeah, that's a good perspective, Raf. I would say I get some people that say that FreeCAD is junk. They'll say, I've tried to do simple things. It just won't work. This is absolute garbage, right? You get some people that make a comment that I should have done this and this and this differently in showing someone how to do that. That's a really common one. And, you know, if you break down a video, you're doing probably hundreds of different operations. I am absolutely sure I'm not doing it the best way all the time, but I'm doing my best. So
no, you should be like, okay, let me see your video. That should be the response.
Yeah.
Jeez.
That would be great.
Well, you should have converted that entity. You should have done a mid-plane extrusion. Like, who are you?
I love that.
CAD police. We should make a troll account on YouTube called CAD police and just go around.
Oh, I love it.
Jeez. These guys.
Yeah, I'll issue some citations of my own, I'll tell you what.
Oh, my goodness. Oh, monetization. So what are some things for people that don't really understand how to monetize YouTube videos? What are some things that a CAD YouTube content creator, some challenges that you face when you want to monetize your videos? What are some like gray areas that sometimes if you don't do this, you can't monetize the video?
Yes. Now I may be showing my age because I started my channel around 2013, 2014-ish. And gosh, I don't even remember now. But they've raised the bar for monetization since then. I know now you have to have, I think, 1,000 hours watched, or 1,000 subscribers. Yes, 1,000 subscribers, a certain amount of hours watched before they'll even monetize you. And if you can get to the point where you get monetized, it should be pretty easy when you're uploading. You can just check the monetization box after that. It's when you upload controversial content, and especially if you have something, say, firearms related or something that has a child in it, and you don't check the boxes that say exactly what your content is, that can put you at odds with advertising. And sometimes if people promote extreme things, I think we've all seen certain channels get demonetized for what content they upload. So.
Oh, I'm scared now. Because
does that answer your question?
Yes, but I know that YouTube now has a feature that they can do a transcript for everything you say. I've seen that feature before. I think it's like a chat box or something like that. But if we say the G word, which I don't want to say it again, that looks like this, then it'll appear on the transcript, and then I guess they'll flag the video, right?
Yeah, and I don't know the full part about the G word that might get taken down or controversial.
This is gonna be a thumbnail.
You can still do the hand sign. They won't find that.
Thumbnail. Yeah. They're gonna flag the whole YouTube channel because of this. It's okay, YouTube. Medical devices, YouTube. We're not talking about that.
Yes. It's a different kind of thumbnail now, right?
Handles. We're talking about handles. Yeah.
Yes.
All right. So another question I have for you is, what has surprised you about being an engineer that you didn't expect before you became one?
Yes, the business side of it. When I was an engineering student, I often just fantasized that I would be designing and doing all these cool engineer things, but I wouldn't have thought that engineering could be so heavy in things like supply chain and supplier evaluations and doing hardcore business stuff. We didn't talk about that very much in school, and we just talked about the technical stuff. And so I found that I was continually learning how to do the business side as I started my career.
You touched on things that you didn't talk about in college that you realized when you became an engineer were important. One of them being supplier evaluations. What's another one?
Yeah, supplier evaluations, supply chain management, often the logistics of how many people are working on a project and what the budget of the project is and how to move talent around and get people what you need while staying within certain budgets.
Okay, let's just talk about two of those if we can. Supplier evaluations. What does that mean?
Yeah, that's a great question, and it's something that is done by some engineers that I haven't gotten to do yet, but it is a lot of evaluating a supplier's capability to meet certain tolerances and evaluating the shipping and logistics and costs of getting involved with the supplier and making decisions on who to go with and why.
Okay, that's what I thought. What about supply chain management? What does that mean?
Yeah, that's a great question. Often when you're in the prototyping phase, you'll say, I need a few of these parts, and you order them and they're sent to another location that you don't have access to, or being able to accurately predict how much of something that you need. And this is some stuff that you run into on occasion when you're just prototyping, but when you're making actual product, it becomes way more important and even a much bigger deal to know how much inventory to have and when. And when you look at problems when you're producing things, and I'm a design engineer, so this isn't exactly my specialty, but when you have problems producing things, let's say you have machinery that is going too slow. Well, you can fix that with inventory. You can build up all this inventory, so when customers order something, you can backfill your inventory instead of make it on demand. But or if you have problems with tracking the right quantity of something to make a product, well, you can just over order your parts, and inventory solves all kinds of problems. But the problem with having so much inventory is that you tie up a bunch of cash resources in having stuff that sits on the shelf. And lean manufacturing, 5S, all these recent trends, even Six Sigma, are focused around how to maximize your process to get as low inventory as possible so you can use your cash resources into developing other parts of your business that will ultimately pay off better. So supply chain management can be a huge advantage when you get it right, and that also comes down to optimizing a process to make sure that you have everything you need and you're maintaining your equipment and everything works.
Okay. Right now, it doesn't sound like that's your main task. You do design engineering, right?
Right. Yep. I did that a little bit more in my last position working in diesel, but now I'm pretty heavily a designer.
So right now, I already have my bachelor's in molecular biology and genetics, and I'm going back to school to get my second bachelor's degree in mechanical engineering because I want to be an engineer that has a degree. That's one of my goals. And I'm taking all the calculus, all the physics classes, and I want to know down the road where you are, what's something in physics that you use frequently, maybe almost on a weekly basis? Because physics is very broad. What's something that you're going to use that you can tell me, Raf? That's my nickname for those of you that don't know. Full name is Rafael. So Raf, what's one thing that I'm going to be using for sure once I graduate, and if I happen to work at a big company that does medical devices, I don't know what the future holds, what's something that I'm going to be doing often in terms of physics?
Yeah, that's a great question. And it kind of depends on the industry that you go into. I started my job in aerospace. And if you asked me that at that time, I probably would have said something like thermodynamics, especially if you're working on the engine side. Then I moved into chemical reactors. And uh, there I probably would have said something pressure related, doing a lot of pressure calculations. Then I moved into diesel and you know, just depending on where you go, there's a lot of principles that come out. I would generally say get a great idea of statics and dynamics. I think wherever you go, you'll probably run into a case where you'll want to calculate the strength of something. And whenever you do an analysis, of course, you want to have hand crank calculations to back up that analysis and not just rely on, finite element to tell you the answer. So that's probably a nice generic place if that answers your question.
Have you ever been in a position where you had to show your hand calculations to support what you just said?
I don't think so, and that's not to say that it doesn't happen. I just haven't been in a place where I was being that strictly scrutinized. But there are times when, in certain jobs, you will, especially if you become an analyst.
When you design handles, which is what you do you do FEA analysis or do you do any kind of force tests?
We have done FEA analysis at my company. I'm not part of that group, so the last time I did FEA as part of a job was doing some pressure vessel calculations and testing.
Okay.
Um, yeah.
So when you design a handle, how do you know that it's going to be able to withstand the pressures, how the doctor holds it? How do you know it's going to hold up?
Yeah, great question. We don't see too high forces that we would generally worry about as far as the handles that I personally have been involved with. But a lot of that is validated in testing. And as on the testing side, I have seen situations get tested that I don't think would ever happen in real life, but the level of scrutiny warrants that. So you can, in my position with the projects I've been involved with, you can design a handle pretty intuitively to know that it's going to be strong enough, but the real validation happens in testing.
Perfect. Well, we're coming here to a close. Is there something that we haven't discussed in this podcast that maybe we should have discussed?
One thing comes to mind, a bit different flavor that we've talked about, is there could be some young or prospective engineers that are listening. And if so, I would say go for it. I was the type of engineer that played with Legos and built things and was imaginative and creative. And I can't say that I was some genius that was, overly smart with math. And if you're like me, there's a place for you. I often had doubted myself because I thought if you're an engineer, you have to be super smart and super good at math. And I changed my major a bunch of times, and when I settled in on engineering, at some points I felt self-conscious that, well, I am with some real geniuses. What can I add that someone else couldn't? And then when I got my second job with chemical reactors, it turns out I was selected to be an engineer over people that were more qualified than me. And it was because I smiled in the interview, I made a joke or two, I was as pleasant as I could be, and they chose me because I could add with my personality. Whoever you are, I think there's probably a place for you in this field because it takes all kinds of people to make the world go around, and that includes being within the subset of engineering. I think, so if you're an engineer, you can totally do it.
Wow, what a great way to close. What an inspiration, and touching on the soft skills and smiling and having a good personality. You play well with others. Those of you that are watching the video, they're going to see you smile constantly throughout the video, and it's been a very pleasant experience. Thank you for being on the show. And how can people get a hold of you if they're interested?
That's great. Yes. On my YouTube channel, hopefully there'll be a link for it. I put my email address in the description. It's Joko Engineering Help, Joko engineeringhelp @gmail.com. And I try to answer everybody. Sometimes I I'm not able to, but I do my absolute best.
Exactly. And that's the same way that he just described is how Joseph and I met. I just sent him an email out of the blue, and he became my mentor, and he's on the podcast now. So everyone, thank you for listening. And Joseph, thank you for being on the show.
It's great to be here. It's an honor. Thank you so much.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.